All right, hopefully by now everybody has watched the video on finding exponents of rational numbers. And again, even if you didn't see the video, you should have been able to do it. Matter of fact, I think Gracie got 100% on it, on the topics on IXL before I even had the video. Because all you need to know to do exponents of rational numbers is the same thing you do for exponents of whole numbers. The base number is the number you use, and the exponent tells you how many times to multiply it times itself. The only difference is, instead of multiplying whole numbers times themselves, you'll be multiplying fractions times themselves, decimals times themselves, integers times themselves. And again, as long as you multiply right, you should have no trouble with that. Now, the next thing we're going to go on to now is square roots. All right? And we talked a little bit about this before your high school placement test. But remember, the sign for square root looks like this. It's called a radical sign. And if anyone says that's radical, dude, that really is radical, dude. That's a radical sign. All right? And again, it looks a lot like a division sign, except for this little line here. And that's not accidental. That's because if I was dividing 3 into 12, I would be saying what times 3 equals 12, our closest without going over, which is 4. Because 4 times 3 is 12. But when you add the little line and make it a radical sign, what you're saying here, if I went the square root of 25, which is the way you read this, you're saying what number times itself equals the number in here. And again, I hope you know that 5 times 5 equals 25. So the square root of 25 is 5. All right? Now, there are actually 15 square roots that you should take the time to memorize by heart, because these 15 square roots are used in some way or another 90 to 95% of the time you ever deal with square roots. So it's very important that you learn them. And here they are. The square root of 1 equals 1. The square root of 4 equals 2. The square root of 9 equals 3. The square root of 16 equals 4. The square root of 25 equals 5. The square root of, 36 equals 6. The square root of 49 equals 7. The square root of 64 equals 8. The square root of 81 equals 9. The square root of 100 equals 10. The square root of 121 equals 11. The square root of 144 equals 12. The square root of 169 equals 13. The square root of 196 equals 14. And the square root of 225 equals 15. And these 15 square roots are used 90 to 95% of the time that you ever deal with square roots. And again, you go, wow, Mr. Du, you're so smart. You knew those so fast. I'm not really all that smart, because you should know them that fast up to here. Because from the square root of 1 is 1 to the square root of 144 is 12, those are your times tables. You see, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, all the way up to 12 times 12 is 144. So if you know your times tables, and I sure hope you do, then all you really have to learn is the square root of 169, the square root of 196, and the square root of 225. And again, to make that even easier to remember, you have the same 3 digits, 169 and 196, where you just change the last 2 digits order. So the square root of 169 is 13, the square root of 196 is 14. And again, that just happens to be the way it works. When you multiply 13 times 13, it is 169. And when you multiply 14 times 14, it is 196. But anyway, learn these 15 square roots. And by the way, you might go, oh, Mr. Du, if that's all I need to know, then this stuff is all so easy. But I said you use them in one way or another. Like, for example, you could be asked to find the square root of this. If I went to the square root of this, you might say, but Mr. Du, you didn't teach me the square root of a fraction. You're right, I didn't teach you the square root of this. I taught you 2 square roots of this, because it turns out in algebra they say the square root of a divided by b is equal to the square root of a over the square root of b. Which means if you want the square root of 16/25, you want the square root of 16 over the square root of 25. And by the way, the square root of 16 is 4, the square root of 25 is 5. And again, if you know those 15 square roots, then you know the square root of 16/25. So to find the square root of a fraction, all you have to do is find the square root of the numerator and put it on top of the square root of the denominator. All right? Now, what if I had something like this? Square root of 5 and 1/16. Now that's the square root of a mixed numeral. Now I could find the square root of 1 is 1 and the square root of 16 is 4. But what about this 5? I can't do that. And it turns out you can't find the square root of a mixed numeral. And you say, cool, then we don't have to worry about it. No, you have to find the square root of it. And you say, but if I can't find the square root of it, how am I supposed to do that? And I say, you can't find the square root of a mixed numeral, but you can find the square root of a fraction. And what kind of fraction does a mixed numeral become? An improper fraction. So you can make this improper by multiplying 5 times 16 is 80 and add 1, and you get 81 over 16. And again, if you want the square root of 81 over 16, you want the square root of 81 is 9, the square root of 16 is 4, and you get 9 fourths. And again, that's improper, so divide 4 into 9 goes 2 times. 2 times 4 is 8, remainder 1, and your real answer is 2 and 1/4. So just like when you're multiplying mixed numerals, you have to make the mixed numeral improper to multiply, but then you have to turn around and make the improper fraction a mixed numeral in the end. To find the square root of a mixed numeral, you have to make it improper to find the square root, but then you have to make it proper again to get the final answer. So that's how you would find square roots of fractions using those 15 square roots that I already told you. How about a decimal? Could you find the square root of a decimal using those? You could. If I had the square root of 49 10,000ths, all I have to do first is find out what's the square root of 49, which is 7. And then you have to, it's not 7 though, because 7 times 7 is 49, not 49 10,000ths. So I have to add a decimal point. Well, if I add a decimal point and multiply 7 tenths times 7 tenths, 7 times 7 is 49, 1 place and 1 place is 2 places, that's 49 hundredths, not 49 10,000ths. So I could experiment and say, well, if 1 decimal place wasn't enough, let's make 2 decimal places, and that's 49, 1, 2, 3, 4 places, and sure enough, that's the right answer. But here's a little neat thing you can do if you don't want to sit there and guess until you get the right number of places behind the decimal. You can look at the number of places behind the decimal and the number under the radical and cut it in half, and that's the number of places behind the decimal in your answer. There are 4 places behind the decimal in 49 10,000ths. Half of 4 is 2. Therefore, your answer has to have 2 places behind the decimal. So if I had something like this, the square root of 121 millionths, again, I would find the square root of 121, which is 11. That's one of those 15 square roots you got to learn. And then I would count 1, 2, 3, 4, 5, 6 places behind the decimal in the problem. Half of 6 is 3, so I need 3 places behind the decimal in my answer. I only have 2, so I add a 0 for the 3rd place. So again, you can find the square root of a decimal by using those same 15 square roots. But you have to find out how many places behind the decimal in your answer. Now, I hope somebody is asking about a problem like this one. 900 thousandths. And again, you go, well, Mr. Do, I just find the square root of 9 is 3. And I count 1, 2, 3, 4, 5 places and take half of 5. Uh-oh. Half of 5 is 2.5. Could I have 2.5 places? 1, 2, add a 0, and then only go half a place? put the decimal point in the middle of a 0? I don't think so. And you say, well then, what's the answer? The answer is, there is no answer. You go, well, that's impossible. It has to be a number that equals this. I say, there isn't. And you say, well, that doesn't make sense. And I say, exactly. That's why this is called an irrational number. Remember when we were talking about rational numbers and the different sets? I told you there were only 2 types of numbers that were irrational that you knew so far. One of them was pi, which everybody knows, and the other one was the square root of a non-perfect square. Well, this is the square root of a non-perfect square, so it's irrational. So if I give you a problem like this, and I will when I test you, you put down non-perfect square, or if you'd rather, you can put impossible. I'm sorry, irrational. So again, I don't care whether you call it non-perfect square or rational, because they both mean the same thing. If you're asked to find the square root of a number that doesn't have a square root, then it's irrational. But it's also called a non-perfect square. So now we know how to do fractions, we know how to do decimals. How about integers?